Hello and welcome to the Sumitomo booth. We are starting our presentation on the dynamic unilayer melting model and the new injection molding machine developed in cooperation with Spiral Logic. This revolutionary reciprocating screw injection unit is able to free the plastic processors from many of the classic molding problems. Ladies and gentlemen, please welcome the new standard for injection molding machines. The Sapphire window barrel was developed to observe pellet movement and resin melting in real time. Man-made sapphire crystal is transparent, has ideal optical quality, and is invisible to infrared. This allows us to easily observe the material inside the barrel with high-speed and infrared video cameras capturing real-time movement and temperatures. Here is the world's first simultaneous high-speed and infrared video of the plastic melting mechanics. At the top is a high-speed video picture. Under the traditional screw design ideas, melting was believed to occur from shear heating in the compression zone. However, in this video, pellets begin melting immediately after entering the barrel. Now, please look at the infrared video below. Shear heating is generated by friction of pellets and not under control. Where the arrow is pointed, this area is heated by uncontrolled shear heat. With the barrel heater set at 200 degrees Celsius, this whitish area shows over 206 degrees Celsius. Typically, we do not see this kind of overheating, which can vary the melt flow and may become a factor for unstable results. Let's confirm what shear heat does by monitoring the pressure in the barrel. The machine was equipped with 7 pressure transducers along the barrel axis to confirm how friction energy in the barrel is generated. This graph shows 10 cycles of the pressure inside the barrel. Now, metering is started. You can see a very high pressure rise in the feed zone. This is showing where high friction is generated. And at the end of the screw, the molten resin has extreme pressure variations. Let's take another look. Metering will start soon. As you look through the sapphire windows, pellets are driven into the molten resin and the pressure graph shows how large this force is. This large pressure force scrapes the interior surface of the barrel with results like this picture. This is a typical machine problem with glass fiber-filled plastics. And again, the left end of the pressure graph shows the molten resin pressure varies with every shot. Even if the screw movement during injection is controlled precisely, such uneven molten resin pressure results in unstable product quality. Please look at this graph showing the machine cushioning alarm. This picture is the molded part of this cycle and the underfilling on the edge. This problem was considered as having no clear reason and therefore no effective countermeasures. Usually this is considered as a typical problem molding engineering plastics and there is no way to prevent the fluctuation. Spiral Logic Limited, by persistent study, found the real cause is connected to the shear heating and developed its screw assembly design. Another typical problem is black spots in the products. This is especially troublesome molding transparent or light-colored parts. The cause of the carbonization is also difficult to define. Some may say the material additive degrading or the powder from pellets can burn black. But what is right? We examined several production screws after extended production. You can see the carbonization occurs only in the compression zone of the screw. Thus, the cause of the black spot is also coming from the screw design. Material carbonization and black spots are unavoidable using screw designs with the compression zone, even with the surface-coated or chrome-plated screws. Now, we are pleased to show you how Spiral Logic solved these problems. The top view is a conventional screw with a compression zone. Below is a new Spiral Logic screw. It is a shorter screw with no compression zone. Spiral Logic uses the heat from barrel for the energy to melt the pellets, and there is no compression zone. The result is no more black spot and no more melt pressure instability because we eliminated the compression zone. We can confirm the Spiral Logic solution by observing the melting mechanics through the sapphire windows. This is a video of Spiral Logic's new melting model and screw assembly. Pellets are melted primarily from the barrel heaters. Pellets are gradually heated and melted without generating shear heat nor overheating. Reviewing the video of shear heat by spiral logic, there is no uncontrolled overheating in the middle of the barrel. Next is the graph of the molten resin pressure. Please recall the previous pressure graph and the very high pressure generated in the feeding zone. With the spiral logic design, there is no uncontrolled pressure rise and the 10 shots of data become almost one line. Repair and maintenance costs are also greatly reduced because the large force in the barrel is eliminated. The most significant improvement is in molten resin pressure stability shown at the left side of the graph. Spiral logic has found the essential conditions for stable injection molding. We compared the traditional shear heating concept and the spiral logic design using the Sapphire windows, temperature data, and pressure data. And we confirmed spiral logic design can produce steady molten resin pressure shot to shot. We can see the improvement with a case study comparing the two screw assemblies molding the same plastic product. The product is a polycarbonate gear. The most critical part is opposite side of the gate, where underfilling easily happens. Top left view is the traditional screw design. The top right is the spiral logic design. The graph shows 60 cycles of the screw position and the injection pressure. The graphs below show the fluctuation of the product weight and the minimum cushion. Pictures of the gear showing the cavity number 2 will change each shot to confirm the quality. If underfilling happens, left of the cavity number becomes black. Please watch carefully. Starting molding. The two graphs on top are overwriting the data. You can see that the pressure graph on the left looks wider. This shows the injection pressure is varying widely. If you notice, the 30th shot of the graph on the left, the peak pressure suddenly dropped, and the screw position during the holding pressure is very different. And the picture on the left shows that the product looks black, a sign of serious underfilling. The graph of the product weight shows the 30th shot weighs 0.015 grams lighter than the others. As introduced earlier, the latest injection molding machines guarantee the precise motion control by using the servo motor and the computer control. But please see how the molten resin pressure fluctuates as long as the traditional shear heat screw design is used. This fluctuation in the melting process is what causes the incomprehensible results. Quality assurance technology, such as the CCD camera monitoring device or the molten resin density feedback system, have been developed. However, not allowing an instability in a production stage must be the first step to quality assurance. Spiral logic solves all of the remaining molding problems by improving the earliest stage of the process, melting stability. For more information, please make an appointment with the Sumitomo sales staffs and experience a new era of plastic injection molding. Thank you for joining our presentation.